Looking at the prerequisite chapter, lesson 6, working with complex numbers, we looked at adding and subtracting those, and those were very similar to adding like terms. We're going to look at multiplying by complex numbers in this video and raising them to a power. And, excuse me, I can't do that. Oh, sorry. We're looking at complex numbers, and we're going to look at multiplying complex numbers in this video and raising them to a power. And raising a number to a power, you remember, is simply multiplying that number by itself. So if we know how to multiply complex numbers, we really know how to raise it to a power, because we would just simply multiply it by itself. Now, multiplying complex numbers is no different, or is very similar to, I should say, foiling, which you may have heard before. FOIL, first, outer, inner, last, which is an acronym or for a way of remembering how to multiply two binomials. Now, I'm not going to use FOIL in the sense that I don't use first, outer, inner, last, because I want to talk more about what FOIL actually is doing. And foiling is actually distributing. And I want to show you how to do multiply binomials by distributing, because FOIL works great if you're just doing a binomial times another binomial. In other words, if you're doing x plus 3 times x plus 7 and you want to use FOIL, that's great. That'll work. And that's okay. But I want you to see that FOIL is actually distributing, and I want you to learn how to distribute, because if you have x plus 3 times now a trinomial, let's say x squared plus 3x minus 7, well, FOIL doesn't work for that. And so now if you know how to FOIL, you're in great shape. But if the problem isn't exactly like two binomials, now you're in a problem. Now you don't know how to do this. So what I'm going to do is show you how to distribute to multiply these rather than foiling, but it is very much like foiling, and you can continue to foil if you want, but I really want you to understand that you're actually distributing. So later in the year, when we're multiplying binomials times trinomials, or one trinomial times another trinomial, you know how to do it because you know how to distribute, and that's really all it is. Okay, so foil if you want. It's much like that, but please take some time to think about what you're actually doing. We're actually distributing. So let's take an example here, and I'll show you how to distribute. So let's take this complex number 2 plus 3i, multiply it by another complex number 5 minus i, and I'll show you how to distribute. Okay, so we have 5 minus i times 2 plus 3i. Now, to distribute, what you're actually going to do, and when you're foiling, this is what you're actually doing, you need to take this, did you get that? You need to take this 2 times this binomial. So you need to multiply the 2 times 5 minus I. And then you need to take the 3i and multiply it by that second binomial as well. So you're actually distributing each of these terms in the first binomial times the binomial. So here we multiply the 2 times 5, then that's 10, and the 2 times the I, that's negative 2i. And then the 3i times the 5 is 15i, and then the 3 times the negative I. Now here's where you have to be careful, and this is the only trick about multiplying. You have 3, positive 3 times a negative 1, that's negative 3. But then you have the I times the I, which is I squared. Okay, and this will always happen in this last term here. Now we have to remember, what does I squared actually equal? I squared is actually a negative 1. So this is actually a negative 3 times a negative 1, because that's what I squared is. And what is a negative 3 times a negative 1? It's actually a positive 3. So this last term right here is always going to simplify by taking this I squared, making a -1, and that's always going to change this sign. So this is going to be 10 minus 2I plus 15I, and now this is a -3 times a -1, which means it's actually a +3. So this is always going to happen at the end when you're multiplying, so be very careful with this last I times an I. I times I is I squared. I squared is -1, which is going to change the sign of this last term. Now that I have it multiplied out and distributed, I simply now do what I did before in the previous lesson. I add them, or I add the like terms. So I have a real 10 and a real 3, that's 13. I have -2I and 15I, so that's plus 13, 13I. So these two multiplied together should equal, if I can get this to work, 13 plus 13I. Okay, so I'll do one more example, and then if I need to do an example video, I will. You let me know, but we'll go from there. So let's do this one here. So this is 2 plus 3I minus, or times, excuse me, 2 minus I. So 2 plus 3I times 2 minus I. So I'm going to distribute. So I take the first term times this whole binomial, and then the second term times this whole binomial, and then I multiply or distribute. 2 times 2 is 4. 2 times -I is -2I. 3I times 2 is positive 6I, and then I have 3 times -1 again, which is -3, but I have I squared times I times I, which is I squared. Now this I squared is actually a -1, so that's going to change this sign right here. So I'm actually going to have 4 minus 2I plus 6I, and then plus 3. The I squared is a -1, changes that sign. Then I go ahead and add my parts. So 4 and 3 is 7. -2I and 6I is a positive 4I. So that would be the answer to this multiplication problem. Oops, that didn't work. So I hope you had the answer, but that was right. 7 plus 4I. That's what we had, wasn't it? Wasn't it? Let me go back. Yeah, 7 plus 4I. Okay? 7 plus 4I. So if you think you got it, go ahead and stop the video, or if you think you might need help with this one, why don't you watch? Okay, it's a square root of -4 plus I times 6 minus 5I. Now again, what you don't want to do is panic. What you want to do when they get complicated like this, a good kind of trick or tip to remember is, well, before I start just trying to multiply that, let me see if I can't simplify this, because maybe simplifying it will make it more simple. Okay, so if I look at this first one, I remember, oh wait a minute, I can't have a -4 square root. What do I do when I have a -4 square root? What can I do with that negative sign? That becomes an I, right? So this is actually I square root of 4 plus I. Now I have a positive square root, which I can take the square root of. What's the square root of 4? 2. So this actually ends up being 2I plus I, and that ends up being 3I. So this -4 plus I, this binomial, actually ends up simplifying to just 3I. So actually I'm going to have then 3I times 6 minus 5I. Well, now we just have a simple distributive property problem that we can go ahead and finish up. So 3 times 6 is 18I, and then I have 3 times -5, which is -15, and then I have I times I, which again is I squared. But what does I squared simplify to? -1. So this is actually -15 times -1, which is actually positive 15. So that's actually end up being then 18I plus 15. That would be the answer. Now, we always want to put our answers in standard form, so we should write this as 15 plus 18I. All your answers should, as a matter of convention, be in simplest form and in standard form, so you want to switch those around. Okay, so that wraps up multiplying these complex numbers. Again, if it looks like it's really complicated, see if you can't simplify that first before you multiply it. Just like we did when we were adding and subtracting, we simplify those I squareds and I cubed to see if it simplified down into the like terms, which we could then go ahead and handle.